All right, here come your formulas. Again, a lot of these, really all of these should look familiar to you. A square. Remember, the thing that makes something a square is that all four sides should be the same, all four angles should be the same. All four sides the same, all four angles the same. So when I find the perimeter, remember perimeters add up all the sides. So I've got a side here, and a side here, and a side here, and a side here, and they're all the same. So like if this side length were 2, then my perimeter would be 2 plus 2 plus 2 plus 2, or 2 times 4. So that's why that perimeter formula. But if you just want to remember perimeter as add up all the sides, that works fine for me. Area is the sides squared. That's why we call it squaring, because it is squaring something is taking the area of a square with that side length. So 5 squared is the area of a square with a side length of 5. Rectangle. Again, all the angles are the same, but the sides are not. So I got 2 pairs of sides that match up, but all 4 sides don't match up this time. And so perimeter there, again, add up all the sides, but 2 of the pairs of sides are the same. So it's just pairing those up. And then area, you may have seen it as length times width. Another way that you'll see it, and the way that I'll write it sometimes, is base times height. Just to let you know, the big ones to make sure that you get written down, the ones to make sure you get written down are all the area formulas, and then for the circle, your circumference formula. So triangle, area is 1/2 base times height. We've done a few problems where we've had to use area of a triangle. And then circle, we have circumference, distance around the circle, and then area is pi r squared. Circumference is 2 pi r. So those are the formulas that you need there. They should all be looking familiar to you. Where we are headed with this is that this chapter, which is going to be the last chapter of the year, by the way. We're in the home stretch. This chapter is going to be all about finding surface area and volume on 3-dimensional shapes. So we're going to be working with spheres and cones and pyramids and prisms, etc. But to do that, for example, with cones, part of the formula for volume of a cone is going to rely on the area of the circle that's in the base of the cone. So we need to talk about those area formulas first. Or if we're talking about a cube, well, that's made up all of squares. So we need to know about the area of a square before we talk about those 3-dimensional shapes. So we're just going to spend these first couple days kind of recapping those ideas before we dive into that.
What is after the 4 R's at the top? It's
4 right angles. It's abbreviating 4 right angles. So this is an angle symbol and then an S after it. And then this is saying the same thing. A square has 4 right angles, and it's got 4 congruent sides. So it's saying all the sides are the same, all the angles are the same. But again, the main thing that you want to write down is your area formulas plus circumference with a circle. All right, and we're going to go forward into getting our last formula written down here, which is trapezoid. And trapezoid is going to be a little bit different because a trapezoid, instead of having these bases be the same, or just having one base like a triangle has, the trapezoid is going to have two different bases. And in a normal year, we'd spend like a whole chapter going through four-sided shapes, and one of them would be a trapezoid. But this year, we don't quite have time to do that. So I'm just going to talk about the trapezoid. Trapezoid, this is just two different ways to write the exact same formula. It's just taking the height and rewriting it out in front. Either way you want to write it. There's about 4 or 5 different ways that different books will write this formula. But the way I usually like to say it is average of the bases times the height. So usually for like a parallelogram or a rectangle or something like that, our formula is base times height. But since we have two different bases, we're basically going to average them together, which is the adding up the bases and dividing by 2 part. So we're going to average those bases together and then multiply it by the height. One pair of opposite sides being parallel is how we identify a trapezoid. The other way you'll see it is, again, you should have two bases that are different. We'll talk more about the trapezoid formula tomorrow. Okay? Circumference area. Again, the trapezoid might be a little bit unfamiliar to you, but all of these formulas are formulas that you should have seen before. Nothing we're going to talk about today should be new. So with that, let's do a couple of examples to start to get us comfortable with using these formulas. This one. Yeah. All right. Find the perimeter, and we're going to do the area. Or in the case of the circle, we're going to do circumference. So for the first one, I'm going to give you 10 seconds, and I want you to write down the name of the shape. Because that will tell us what formulas to use. And hopefully you picked this out as being a rectangle. Because all of those angles were right angles, but the sides were not all the same. Perimeter, area. Here we go. Perimeters add up all the sides, so let's count out all the side lengths here. I got 1, 2, 3, 4, 5 as this base, and that means this base up here is also going to be 1, 2, 3, 4, 5. And then my other two sides are both 1, 2, 3, and this one's also 1, 2, 3. So to get perimeter, I just need to add all those up. I've got 3 and 5, and then another 3, and then another 5, which is going to be 16. There's my perimeter. Area. Area is just length times width, or base times height, as I'm going to write it. However you want to think about it. Either way, that's going to be 5 times 3, which is 15. Done. Okay, nothing too terribly difficult today. All right. 10 seconds. Come up with a name for that shape. All right, time's up. Everyone put rhombus, right? Yeah? I'm just kidding. It's a triangle. Identified by the fact that we've spent like 4 chapters this year on triangles. I hope you can identify one by now. Perimeter. Add up all the sides. And a triangle, as you know, has 3 sides. There are 4 measurements, so there's one of them that we're not going to use. Here is side number 1. Here is side number 2. Here is side number 3. The 15 is not used in the perimeter because it's not a side. Add up all the sides. We have 48. We have 20. We have 39. That's 68 and 39 is 107. Let's talk units. My units here should be in centimeters. I'm just totaling up distances to get the distance all the way around the shape. So there should be a total distance, which that should be in centimeters. Area. Area of a triangle is 1/2 the base times the height. Base and the height are perpendicular to each other. So here is why this 15 is drawn in. There's my base, there's my height. They're perpendicular to each other. So this is my height, and this is my base. So 1/2 48 times 15. Which should be 360. Centimeters squared this time, since we have an area. Area should be in our units squared. So centimeters squared. And if you look in the formula itself, we're doing 1/2 the base times the height. So we are taking half of centimeters times centimeters, and centimeters times centimeters should be centimeters squared. All right, this time it's definitely a rhombus. Oh no, it's not a rhombus. What is it? We spent a whole chapter on it once again. Circles. So this time we don't talk about perimeter for distance around the circle. We talk about circumference. Because definition of perimeter is add up all the sides, and a circle doesn't have any sides. So you need a different word for distance around the circle. That's circumference. So circumference, I'm going to do this one quickly. 2 pi times my radius. Since 5.8 is my diameter, my radius is going to be half of that. So that goes in for my radius there. So my circumference, 2 times 2.9 brings us back to 5.8. Take my pi, stick it at the end. Kilometers. This is keeping my answer in terms of pi. area. See if you can work ahead of me and get the area. Remember that our units for area should be in kilometers squared, since we're talking about an area. That's because my radius, which is in kilometers, is getting squared. So my units should be kilometers squared. Hopefully we plugged in 2.9 for our radius into pi r squared. And that's going to be 8.41. That's 2.9 squared. And then we're going to take our pi and put it at the end. And like I said, kilometers squared for our area. So fairly straightforward. We're going to practice more of these, particularly area ones, tomorrow.